Every year, floods are caused by typhoons and torrential rains worldwide, causing a lot of damage. Flood affected areas are not easily accessible by humans, and this is where drones come in. We employ unmanned drones for efficient flood detection. The 2015 Chennai floods almost killed 500 people and over 18 lakh people were displaced, with estimates of damages and losses ranging from nearly rupees 200 billion to over 1 trillion. Over the past few years, unmanned aerial vehicles have gained considerable interest as a remote sensing platform for various practical applications such as traffic monitoring and search and rescue. We focus on the automated aerial scene classification of flood affected areas from a UAV. Why are we unique? We have come up with a novel technique to capture and detect feed in real time, which reduces the need for human intervention. Our drones are autonomous and all the work done is made easy without any command or handling by the user at the ground station control. A major plus point is that we reduce the runtime drastically and thus increase more area to be covered in less time. A semantic segmentation network classifies every pixel in an image, resulting in an image that is segmented by class. Reinforcement learning is a machine learning training method based on rewarding desired behaviors and punishing undesired ones. We employ optical flow algorithm to accelerate learning. Optical flow or motion estimation is a fundamental method of calculating the motion of image intensities. We employ transfer learning, where we use a pre-trained AlexNet model for classification and detection of flood. Transfer learning generally refers to a process where a model trained on one problem is used in some way on a second related problem. First, the semantic segmentation model. The semantic segmentation model uses 1. A simulation 3D scene configuration block, which sets up simulation with the US city block scene. Number 2. A simulation 3D UAV vehicle block, which specifies the driving route of the vehicle. Number 3. A simulation 3D camera block, which is mounted to the quadcopter, which captures data from the flight. This block outputs the camera depth and semantic segmentation displays by using 2 video display blocks. On the bottom left, you see the semantic segmentation model. On the bottom right, you see through the camera on the drone, and the top video shows how the UAV is flying. Next is the optical flow algorithm for obstacle avoidance. Optical flow or motion estimation is a fundamental method of calculating the motion of image intensities. Let's look at the subsystems. First, the sensor inputs. So these input the camera view and estimated position. Then we have optical flow lines calculation. This calculates the optical flow lines for the image using the horn-shunt method. Here the input image is obtained from an onboard camera, and then the optical flow lines are calculated using horn-shunt method. The algorithm is then implemented for steering the vehicle using calculated flow lines. A switching based logic is then implemented to switch from optical flow algorithm to a PID control algorithm. The drone navigation is visualized using the VR sync block. And then finally, we have the classification ML model. We have used the MATLAB framework to build the deep learning model. We have utilized transfer learning with AlexNet architecture, providing an accuracy of 96.2% in classifying the images into flooded and non-flooded areas. Our goal is to deploy the flood detection system using the drone in the real world. We have tested our drone through simulations using MATLAB and have come up with a feasible and efficient model. Our prototype is in the making process, which integrates these core concepts into one whole design. Thank you for this opportunity, and this team includes Bharat, Kamya, Kriti and myself, Jay Sharan.